Question 10 is a short word problem question, although luckily in this case you don't have to set up any equations for yourself, which is usually the most difficult part in word problem equations. Okay, I'll read this to you, but I suggest you read it on the question paper as well. An industrial process requires water to flow through a system as part of the cooling cycle. Water flows continuously through the system for a certain period of time. The relationship between the time t from when the water starts flowing and the rate r at which the water is flowing through the system is given by an equation. So they give us this equation. The rate r at which the water flows through the equation is given by r equals negative 0.2 t squared plus 10t. And t is our time in seconds. R is the rate. Okay, 10.1. After how long will the water be flowing at the maximum rate? Okay, maximum rate, maximum or minimum, we use differentiation to find those turning points. In this case we can see the highest power is a 2, so it's a square. That gives us a parabola. And we can see it's a negative a value in this parabola, which means it's this shape. So obviously the maximum rate would be at that turning point. And the turning point has a differentiation value of 0. I mean, a gradient of 0. So if you differentiate and put the answer equal to 0, that'll give you your x value at that point. And that is our time, and this is our rate. Okay, so let's do that. All we need to do is differentiate r. So differentiate negative 0,2 t squared multiplied by 2 gives us negative 0,4 t. And 10t, if you differentiate that, just becomes plus 10. And now we want to set this equal to 0. So this is the gradient. We want to find out where the gradient is 0. So 0 equals negative 0,4t plus 10. Move the numbers to one side. We get, so we'll take this whole t value to the other side. So we get 0,4t equals 10. Divide both sides by 0,4 and we get t equals, this is the same as 2 over 5, so it becomes multiplied by 5 over 2 is 50 over 2, which is 25. And that is your, so 25 seconds. Don't forget to write in the units. So after 25 seconds we have our maximum rate of flow. 10.2. After how many seconds does the water stop flowing? Okay. As we can see from this picture here again, this is the rate. So when the rate is either here or here, the rate is 0. It means there's no water flowing through. So that means we have to find the x cuts. And obviously it cannot be on a negative side. It will have to be, if there's a negative and a positive answer, it will have to be the positive, because you don't get something like negative time. So what do we need to do to find the x cuts? Well, we say in the original equation 0 equals negative 0,2 t squared plus 10t. So we have to factorize this. Take it a common factor of 2t, and then we get negative 0,2t plus 10 equals 0. So something times something equals 0 must mean either one of them is 0, as we discussed before. So t equals 0, or negative 0,2t plus 10 equals 0. In this case t equals 0, and over here if we solve for t we get that 10 equals 0,2t, divide both sides by 0,2, and we're left with 50 equals t. So after 50 seconds the flow will stop completely, and it starts at 0 as well. So it starts at 0, then it starts increasing in flow, and then at 50 seconds there's no flow anymore. So that's it, and we can see this is symmetrical because the turning point of a parabola has to be midway between the x cuts, and we see this is true. Between 0 and 50, midway between that is 25 seconds. And that's it for question 10.